I'm Catherine Welsh, I'm a student in chemistry at the University of Edinburgh, and today we're going to demonstrate how to do UV vis spectroscopy. So we're using a UV 1800 spectrometer, and it is a double beam instrument. So one beam comes in and gets split into two identical beams, with one going through the sample and one going through the reference to get spectra for that. The absorbance of the solution is recorded at every wavelength given in the range on the computer, and this is related to the intensity of light passing through the sample at the wavelength. Once we've done that, we need to select our cuvette depending on what we're using. So the three most common types of cuvette are PMMA, quartz glass and glass. Quartz glass is commonly used for UV absorption solutions, so clear solutions. PMMA is used for visible absorption, so coloured solutions. And glass cuvettes are most often used for organic solutions that can commonly dissolve the plastic in the PMMA. You can also get cylindrical cuvettes for the gas phase samples. When using the cuvettes, we must hold it by the faded sides to ensure that the clear side that the beam goes through has not got any marks on it, and once we've added the sample, it has to be wiped down to ensure the residue is taken off the face. So we are measuring the absorbance of a potassium chromate solution in sodium hydroxide. So for our reference, we are using the solvent sodium hydroxide. So this will be filled to 3/4 as the beam goes halfway through the cuvette. So if it's filled to 3/4, it will ensure that there is no errors in that. Once the solvent's been put on, the cap is put on to avoid evaporation, and the sides are wiped down to remove any residue. The reference is put in the reference section with the arrow side facing into the beam. For the baseline reading, the solvent is put in the sample container as well, to allow a baseline to be produced. There we go. The cuvettes are pushed down properly to minimise errors and enhance reproducibility. So then we close this, and to take a baseline reading, we click on baseline rather than auto zero, because auto zero will force any absorbance to be zero, whereas baseline is used to get the background. So because we are ultimately measuring the absorbance of a coloured solution, the wavelength range we use is 800 to 350 nanometers. So then we just click OK. And our background is being produced. An identical cuvette is used for the potassium chromate sample as was used for the sodium hydroxide background sample, and it's once again filled to 3/4 full to minimise errors. And the cap placed on to reduce evaporation, and the sides wiped to remove any residues. Potassium chromate is then put in the sample container with the arrow pointing into the beam, and we then press start as the baseline has been and we wait for it to run. And we can also scale the spectra produced. So here we go. So we can see that the maximum absorbance occurs here, and then this can be produced for different concentrations of the sample to measure the extinction coefficient of the potassium chromate, or other way around. If the sample is unknown, a calibration curve can be produced, and then the extinction coefficient used to calculate concentration. The main errors in this experiment are if the cuvette is not properly pushed to the bottom of the reader due to the results being irreproducible. A tissue must be used to keep the cell wall clean, and systematic errors couldn't result from a mismatch in cuvettes. Thank you.